Great, thank you for inviting the town to come and speak today, and thank you for that lovely introduction. I'm here to basically speak about how clean technology is being implemented in today's communities. So what's actually making it to market and what municipalities are investing in. The town's been investing in clean technology for about over 10 years, and we've got some pretty phenomenal projects now that are up and running that we have results on. So I'm going to go through those today. So the town of Okotoks, I'm sure all of you know where it is. It's just south of Calgary. It's a small community, about 23,000 now, so it's grown quite quickly. And it's a really good community to look at for technology because of its size. So we're able to monitor everything really easily compared to large cities such as Calgary. So back in 2000, we started the concept of EcoEfficiency, and we created an EcoEfficiency fund, which basically went towards the beginning making all of our big cost items more efficient. So we looked at things like our ice rinks, our pools, our wastewater treatment facility, and we said, okay, well, we have to make these more efficient. So through upgrades at those facilities, we did things like the de-superheater at the ice rink, which basically pulls heat off of, when you're making ice, you create a lot of heat when you're trying to cool things down. So pulling the heat off that, we basically redid all of our lighting and all of our facilities, variable fuel pumps at our wastewater treatment plant. Really basic steps at the beginning. But out of this first stage, we obviously saw benefits in all of our facilities. And the results from the first stage were a 30% total reduction in our energy use across the board in all of our facilities, which estimated to an equal of 1,200 tons of greenhouse gas reduction. So that was just stage one. So we thought this is pretty good results from just a couple steps. So we did the next stage of phase two of our project, which happened in kind of 2002 onwards. And we decided to invest in solar technology. At first, we did solar thermal technology, so the concept of space heating over creating electricity. So we put a large solar thermal hot water system at our pool. So our pool is 100% heated with solar hot water. So that's two pools plus a hot tub, and all of that extra heat that isn't used for that gets dumped into the domestic hot water system at the pool. We also purchased 2 solar Zambonis, which has a huge payback as well. So all of our hot water that we're constantly cleaning the ice every hour or so is solar heated. And then again, a solar domestic hot water system for our fire hall, for our firefighters, etc. So you can see at the top there we have 2 different types of technology. We have the flat panel solar technology, and we also have the evacuated tube. The flat panel was a little bit earlier. Solar evacuated tube came later. You'll hear arguments on both sides saying which one's better. So we've seen equal benefits from both. So we've had success with both systems. Issue with flat panel is if you lose one panel, you lose the whole series. Whereas with the evacuated tube on the far top right, like a light bulb, you can screw out one tube and replace it without losing the power of the whole system. And you can see on the bottom right a detail of the evacuated tube. Inside those tubes and the flat panel, all we have is a water glycol solution that gets pumped through that collects heat and takes it to a hot water tank. Really, really simple system. We also did solar thermal space heating, not just through evacuated tube, but through solar walls. So you can see on the top right, that's our rec center. We have a solar wall. What it does is it preheats the air into the facility, so we're not heating from a -30, we're heating from over 0 degrees Celsius, so there's less energy required. Those systems had a payback of 3 years. They were phenomenal, whereas solar thermal panels for hot water are about a 10 to 15-year investment that we were seeing. After that, we decided let's get into the PV side of things and let's start seeing if we can add some energy savings through electricity. So we did a PV system at our recycling depot for its lighting and also for the municipal center. And we also have quite a few security lights around the town that are just solar panel, or solar powered. PV, we still haven't seen a huge payback. We did these about 5 to 7 years ago, the different projects. PV is now becoming more cost effective compared to solar thermal. Originally, solar thermal was a much more big bang for your buck. However, PV is coming a long way, so I think in the future we're going to start investing more into PV. So far, we're not seeing a huge payback on these systems. So you can see between all the buildings, it's hard to compare because some buildings were only 15% savings. Places like the rec center, hard to see because they have such a huge capacity, high use. However, places like the fire station and the municipal center were 80% savings. So you can see on these graphs too, we basically the town procures 80% green energy as well. So we're not running all the pumps on these solar thermal systems with electricity powered by coal. We're making sure we purchase 80% renewable, which is a mixture of obviously wind and also hydro, et cetera, that we import from other provinces. So we just buy that off the grid. And you can see even though our energy has increased, usage because of our population has basically doubled in 10 years, our greenhouse gas emissions have actually decreased. So even though we're using more energy, we're using energy more wisely. So because of all those little initiatives we had at the town, we were lucky enough to get the Drake Landing Solar Project, which I'm sure some of you heard about. It's hit world record this year. It's basically the very first neighborhood in the world to have 80% solar fraction, which means that 80% of the homes are heated, 52 homes are heated with solar heating. When it's fully charged, which will be in year 5, we're in year 3 right now, it'll be at 90 to 95% solar fraction. So you can see there all of the, there's basically a just under 800 solar panels, solar thermal flat panels on all of the garages. On each of the homes, they have 2 individual panels you can see on their south-facing side. That's for their own domestic hot water, separate system from their solar thermal heating. I mentioned, this is pretty much the same thing I just mentioned, the 52 homes. You can see just the detailed. They all look pretty regular. That was the main concept behind the builder. I should mention that's really smart thing too, is it was a really interesting project between a community builder, a home builder, a town, Natural Resources Canada, lots of different people getting together to make new technology work. So as I mentioned, it hit 80%. The idea is we collect solar heat in the summer when we get the most of it, and then we use it in the winter when we need it the most. And we're the first in the world to hit this record because we decided to store it underground. So basically all summer, we push hot water underground, which I'll show you in a second. So these are just some of the stats that the program has hit. It's the first also to have our 2,000 homes of that capacity, which means that, again, we started with efficiency first. We said, why would we put a regular home in there it's quite leaky and put new technology in it? So these homes are also quite tight. And also, obviously, the first in the world of this size. So why space heating? Almost 65% of our energy needs are for space heating in Calgary region. And that works out to be 17 barrels of oil a year for each home. And obviously, why do we do this kind of system is you can see on that bottom left graph, we have peak summer energy in the summer, but we need it in the winter. So we need to swap those 2 curves. And Okotoks is an ideal location because this part of Alberta and southern Saskatchewan get about 300 to 400 more hours of sunshine per year than the rest of Canada. So this is the solar belt of the nation. This is the most important section of the presentation, showing you the energy consumption savings. So you can see the orange section is basically being offset. The reason why Drake Landing home on the right is actually shorter than the typical home in general is because of the energy efficiency to start with. So the homes are much tighter. And then you offset all of that typical gigajoules of energy required with solar. And then you can see in the end, we end up with a 5.65 ton GHG reduction emission annually. So these homes are phenomenally a lot less energy than the ones across the street that are built at the exact same time. So I should mention that it's estimated that the 52 homes will require approximately 3,000 gigajoules of thermal energy for space heating annually, which is going to be about 70 to 85% less than the average home. So that's the key point there. 52 homes will have the same impact as 3 baseline homes at the same age and size. So sorry, I'll have to fly through this. I'm running out of time. But here's what the system looks like. It's really simple. It just pulls the heat off the garages. And there's different pumps inside the facility. Basically, it just mixes different temperatures and then delivers the heat back to the homes. The homes don't have furnaces. They have heat exchangers instead. So hot water is pumped through the homes through their heat exchanger. This is the key to the entire project, the borehole. So basically, the idea is we need to store that summer heat. So we push it down into a field about the size of a small baseball diamond, pump it down 30 meters into the ground, and we actually heat the soil. So by the end of summer, the soil will be at approximately 80 degrees Celsius. We'll pull off that heat all winter until the very end of February when everything's kind of equal to nice 42 degrees. And that's when we need to start pulling on other gas resources, such as natural gas, to top up that little 10 to 5% of heating requirements. So I'll try to fly through this. Basically, why is it successful? If you were to crunch the numbers in your head, this project was $7 million. It wouldn't make any sense to build 52 homes. Because it was a research project, they've basically optimized how solar thermal energy works. So when the federal government now wants to build another example and mix in other technologies, they basically have the optimum design now, and you won't need to build as much infrastructure. So I'm sorry I had to go through that so quickly. If you have any questions, I can answer them.